So here we are with other types of equations, part 2. Once again, this is kind of tough stuff, folks. I know that you've been exposed to part of it before, so you got to pay really close attention, take good notes, write down your questions, and we will answer them in class. All right, so equations with rational exponents. That's an exponent that's a fraction. A ratio is a fraction. All right, so a couple things to review. A raised to the m over n power is the same thing as the nth root of a to the m. The denominator is the index. The numerator is the power. Okay, and we can write this with the m on the inside of the radical sign, or put parentheses around the whole thing and take the m to the outside, either one. Okay, the square root of 4, and once again, if there's no little index here, you assume that it's a 2. And so that's going to be plus or minus 2. When your index is an even number, then you're going to have 2 roots, or 2 possible roots. So 2 times 2 is 4, and negative 2 times negative 2 is also equal to 4. If I take the cube root of negative 8, that would be negative 8 raised to the 3rd power. That's going to be negative 2. In the case of the index that's even, you're going to have 2 roots. In the case of the index that is odd, and remember this is the index, you're going to have 1 root. Okay, so let's solve this. Solve x to raise to the m over n equals k, where k is any constant value. First of all, you have to assume m and n are positive integers, and m over n is in lowest terms, and k is a real number. Okay, that's kind of the rules we live by here. So the first step is to isolate the expression with the rational exponent. Same thing like we did with just with a radical sign, okay? All right, so then raise both sides of the equation to the n over m power. If I have x raised to the 1/2 power, if I square that, that'd be 1/2 times 2, which is 1. So what you're really going to do is you're going to take whatever your exponent is, m over n, and you're going to multiply it, or you're going to raise it to the n over m power, and that cancels everything out. All right? So this is a little confusing. If m is even, then x to the m over n equals k. When you raise both sides to, see how I have raised it to the inverse, or the reciprocal? Then I have to put plus or minus. If m on your answer turns out to be even, you're going to have 2 roots. Okay? So x is going to be plus or minus k over the n, k raised to the n over m. If m is an odd number, then when we raise both sides to the n over m, you have n over m. Your index is now odd, which means you only have 1 root. Okay, example number 5. Solve. 3x raised to the 3/4 power minus 6 equals 0. So we're going to isolate our x by moving the 6 over to the other side and then dividing both sides by 3. So I have x raised to the 3/4 power equals 2. The reciprocal of 3 over 4 is 4 over 3. And 3 is an odd number, and it's going to end up on the bottom on the other side, so that will be our index, and an index that is odd has an odd, or has only 1 root. Okay, so we're going to raise both sides to the 4 over 3 power. So that means x is going to be 2 to the 4/3, and the reason for that is because 3/4 times 4/3 cancels out. Now, you can't do anything more with this. That's kind of like, you know, unless you want to do a decimal, which we don't want to do. So that will be my answer, x raised to the 4 over 3 power. You can't take the 3rd root of 2 and come out with an integer, so we're going to leave it like that. So to check it, we say 3 times 2 to the 4/3 power times the 3/4 power equals 6. Well, 2 to the 4/3 times 3/4 is 2 to the 1, so 3 times 2 equals 6, and that works. Okay, the next one is going to be x to the 2/3 power minus 3/4 equals minus 1/2. Now there's those pesky fractions again, but I'm going to add 3/4 to both sides. And 3/4 minus 1/2 is 1/4. So my index is 2/3 I'm sorry, my exponent is 2/3, so I'm going to multiply by 3/2. I'm going to raise it to the 3/2 power. And on the left-hand side, 2/3 times 3/2 is 1, and x to the 1 is just x. So x is going to be the square root, because there's your index, the square root of 1/4 raised to the 3rd power. You're going to have two roots. So when you take the square root of 1/4, you get plus or minus 1/2. When you raise that to the 3rd power, you get plus or minus 1/8. A lot of arithmetic here. So go do your checkpoint number 5. Okay, equations in quadratic form. I'm going to do a little chart here. The equation, the substitution, and the new equation. So if I have an equation like this, x to the 4th minus 10x squared plus 9, I want an easier way to be able to factor that. And what I'm going to do is I'm going to think of x squared as the variable u. And if you see that x squared squared gives me my first term. So if I change this x squared to a u, then this would be u squared. And my new equation would be, if u equals x squared, my new equation would be u squared minus 10u plus 9 equals 0. And I can factor that. All right? We'll get some practice on that. If I have 5x to the 2/3, let's talk about rational exponents, plus 11x to the 1/3 plus 2 equals 0. Well, I can see that I have 1/3 here, and if I take 1/3 and square it, I have 2/3. So this is a great candidate for this kind of a problem. If I let u equal x to the 1/3, then I will have 5u squared plus 11u plus 2, just by substitution. And then I can work with those problems. So let's get an example going here. Example number 6, solve x to the 4th minus 8x squared minus 9 equals 0. Okay, it's pretty easy to see that I have an x squared and an x squared squared. So if I let u, or I can rewrite this, x squared squared minus 8x squared minus 9. If I let u equal x squared, then I can do my substitution here. Wherever I see that x squared, I'm going to put in a u. U squared minus 8u minus 9 equals 0, and that factors to u minus 9, and u plus 1 equals 0. Now, you have to go back and resubstitute. The u is x squared, so instead of u minus 9, I'm going to have x squared minus 9 plus x squared plus 1 equals 0. Now factor that. If x squared minus 9 equals 0, then x is plus or minus 3. If x squared plus 1 equals 0, then x is plus or minus I, because it turns out to be x squared equals negative 1. And you need to go back and plug those back in and see if they work. I'm going to tell you they do work, so we don't waste too much time. So go ahead and do checkpoint number 6. All right, another example. This is with a rational exponent. 5x raised to the 2/3 plus 11x to the 1/3 plus 2 equals 0. I have 1/3 and I have 1/3 squared. So if I let my u equal x to the 1/3, then I will have 5x to the 1/3 squared is going to be 5u squared. So 5u squared plus 11u plus 2 equals 0. Now, just a quick reminder, you can either factor this by the Beges and Bagash method, or you can do it by factoring and regrouping. So a product of, I need two numbers whose product is 5 times 2 and whose sum is 11, and that would be 10 and 1. So I'm going to take my 11u here and I'm going to rewrite it as 10u plus 1u. And then I go ahead and put my 5u squared and my plus 2 at the ends. Now I have things that I can regroup. When I regroup my 5u squared plus 10u and factor out of 5u, I have 5u times u plus 2. And when I factor a 1 out of this, I have 1 times u plus 2, which means I can put these together. 5u plus 1 times u plus 2. Now, if 5u plus 1 equals 0, then 5u equals negative 1, or u equals negative 1/5, but u is equal to x to the 1/3. So substitute back in here. I have x to the 1/3 equals minus 1/5. I'm going to raise everything to the third power to get rid of that 1/3. So x is going to be equal to negative 1/5 cubed, which is negative 1 over 125. On the other side, I have u equals negative 2. Well, u is equal to x to the 1/3. So I'm going to raise both sides to the third power. So I will have x equals negative 3 cubed, which is negative 8. Okay, and they both do check. So go ahead and do checkpoint number 7. Okay, let's talk about some absolute value here. If I have the absolute value of 2x minus 3 equals 11, that means that what is inside here, what's inside the, I don't know why I'm not writing here. Okay, what's inside there can either be positive 11 or negative 11, because when you take the absolute value sign off of it, it becomes positive. So either 2x minus 3 is 11 or 2x minus 3 is minus 11. And when we solve these, I get either x equals 7 or x equals minus 4. And you should go ahead and check them, and when you check them, you get 14 square root of 4, or I'm sorry, square root. Absolute value of 14 minus 3 is 11. And absolute value of negative 8 plus negative 3 is equal to 11, which it is. So that checks. So both of those are good roots. So do your checkpoint number 8, and I think we have one more to go here. Example number 9. When you have absolute value, just like all of the other problems we've done in this section, you have to isolate that. So I'm going to first add 15 to both sides and then divide by 5. So now I have my absolute value all by himself. Absolute value of 1 minus 4x equals 3. That means either 1 minus 4x equals 3 or 1 minus 4x equals negative 3. And when I solve these very simple problems, I get x equals negative 1/2 or x equals 1. And I need to check them. Okay? If I have negative 1/2, when I work this out, I get 15 minus 15 is 0. So negative 1/2 does work. Okay? And when I use my 1, I have 5 times 3 is 15 minus 15 is 0, so that one works too. So do your checkpoint number 9, and there's the baby. See you later, guys. Bye.